right, welcome back to this channel, and I hope you're good. Now you might be wondering, why am I so happy, why am I dancing? Now I was just coming back. Actually, I alighted from a vehicle, so coming down from that vehicle I was really pressed and I had to use myself, but there was nowhere, so I just had to rush since I was already close by. Getting home, I eased myself and I felt so relieved. Now why am I saying this? Today's topic is a bit about something, the urine. Now, when we ease ourselves, we feel relaxed because there's this urge that come or disturbance that come when you don't release urine. Now, the urinary system, what is this system about? It consists of actually two kidneys, of course we know. Is anybody that has more than two kidneys? No. So the urinary system consists of two kidneys, a left and the right kidney, and then two urethra, just like you can see in this diagram here. Two urethra connected to these two kidneys. That's what pass the urine formed down to the bladder. So where is this urine actually formed? This urine is actually formed in the kidney, and then it trickles down into the two ducts we refer to as the ureter, and then they enter into one bladder, and then it's stored there. When the bladder feels the need to empty its contents, it passes out through another passage we call the word urethra out of the body. So now let us look at what this urinary system. So what is this urinary system? Particularly, let us look at the kidney. The kidney, which is a major organ that's what forms urine. So stay tuned and we'll be right back. Alright, welcome back. The diagram here, as you can see, is a longitudinal section of the kidney. Now, what is this kidney and where is it located? The kidney is a bean-shaped organ that is located at the at the lower abdominal region behind. Yes, behind, located on both sides of the vertebra. Now, the kidney is one organ that does a major function. That's whenever somebody's kidney is said to be dysfunctional or probably affected by one disease or the other, there is cause for alarm. Yes, because the kidney does a major function, which is what? Filtering the blood. The kidney filters the blood. Yes, it actually filters waste out of the blood. Now, the kidney is said to be the mother or a mother in a kitchen producing something. What of course is a mother cooking up? She's cooking up a meal. Now, in the case of the kidney is producing a urine. But what are the ingredients used to produce this urine? Actually, the ingredients rather are gotten from the word sieved blood or filtered blood. Now, the blood is known to be brought to the kidney by a major artery we refer to as the aorta, A-O-R-T-A, as you can see in the diagram. Now, this blood comes into the kidney, but because the kidney is two, this aorta, which is one, when it comes down to the section of the kidney, it divides into two, the right side and the left side of the kidney. Now, dividing into two sides, kidney is actually the aorta, which is the major artery that brings blood to the kidney, divides into two on getting to the kidney because the kidney is two. So one part of the aorta, when it divides into two, it's called an artery because the aorta is a major artery. So on dividing into two, it is now called an artery, no longer an aorta. One goes into the right part of the kidney, and this is called the right renal artery, and the other goes into the left part, and this is called the left renal artery. Now, on bringing blood to this kidney, there are different segments in the kidney that would filter this blood, meaning that the blood will pass through different segments of the kidney. Do you understand? Now, at the end of the process, we're going to look at those parts of the kidney that the blood will pass through. But at the end of the process, you will notice that there's also a vein there. Now, the vein does something. The vein is known to take blood away from organs back to the heart. So at the end of the filtration process, that is after filtering the waste out of the blood and getting the fluids and the excess fluids and the waste, nitrogenous waste gotten from mostly protein products. So when this waste is leaving, it leaves through two ducts. The first duct is the collecting duct. The second one is a blood vessel referred to as the vein. Do you understand? Now, Back to the kidney. When you look at the kidney, it is said that, just like I said earlier, that each kidney, either the right or the left, has nephron. Now, what is nephron? Nephron is the unit of the kidney, meaning it is that smallest part of the kidney that does the work of producing what? Urine. Do you understand? So each kidney has millions of nephron, and these millions of nephron will produce drops of urine, which all of them will gather together into a duct or a passage we refer to as the what? Collecting duct. Now that collecting duct will now lead to the what? Urethra for each kidney, and then at the end of the day, the collecting duct passes urine down to the urethra, and then from the urethra down to the bladder, where it is temporarily what? Stored, as you can see in the diagram, the movement. Now let us look at another chart that shows us the unit of the kidney called the nephron and its parts. Now, the outermost structure of the kidney is covered by a membrane. We call it the what? The cortex. But before the cortex, we have another membrane, more like a sac-like membrane. Now, the outermost part, which is the cortex, has major parts of the nephron inside. And this major part of the nephron are the Bowman's capsule and the glomerulus, as you can see in the diagram. Then the other part of the nephron is inside the what? The inner part, which is the medulla. Now this medulla has the part we refer to as the loop of Henle's, or sometimes we call it the Henle's loop. Now the structure of the what? The renal artery that brings the blood to the kidney for it to be filtered. The renal artery is structured to have a wide, duct or wide passage, because blood comes in with what? High pressure. Now, this renal artery is branched into what we call the what? Afferent what? Arterioles. Now, this afferent arterioles will now branch into and together with the what? Vein coming from the other end. So the other end, the vein branches into tiny branches we refer to as efferent what? Arterioles. Now, both the vein and the artery will meet to form what we call capillaries, because wherever you have the meeting together of the arteries and the vein, it forms what we call capillaries. Now, a capillary is that part where the vein and the artery meet and exchange of blood occurs and waste occurs, and also it is known to have one cell thickness. That means the capillary has one cell thickness. Unlike the vein that is thin, the artery is known to be thick to withstand the high pressure of blood that passes through the what? Artery. Now, whenever this blood comes in, it comes in, both the artery and the veins will mix together or combine together to form a highly specialized capillary, which we refer to as the glomerulus. The glomerulus brings blood into a cup-shaped structure we call the Bowman's capsule. Yes. Now, what does the Bowman's capsule do? The Bowman's capsule, just merely looking at the shape, will tell you that it filters blood. It has a cup or funnel-like shape that filters the blood that is brought in by the what? Arteries and the veins. Tiny arteries and veins we refer to as afferent arterioles and efferent arterioles. Now, when this blood is filtered, the liquid that passes through the glomerulus is called through the Bowman's capsule rather, which is the cup-shaped structure. The liquid that is being filtered passes through the what? Bowman's capsule, and this liquid is called the what? The glomerular filtrate. Of course, from the word filtrate, it tells you that this is what has been what? Filtered. So when it passes into this Bowman's capsule, now it is passing in through whatever is being filtered are tiny molecules or tiny substances like what? Nitrogenous waste like urea, uric acid, also salts, ions, and then some higher molecules will not pass like the blood plasma. Now, this first part of the Bowman's capsule that goes down is coiled. It's called the what? If you notice that a coiled part, we refer to that coiled part as the what? PCT, the proximal convoluted tubule. Now, anything proximal has to do with something that is close. Because it is the first part close to the Bowman's capsule, we call it the proximal convoluted tubule. And then you see that the tube has a part that straightens and forms a U-shaped loop. That part is called the loop of Henle's. And then it has another part that ascends up. As it goes up, it coils again to form a what? DCT. That DCT means the distal convoluted tubule. Distal is just an English word that means something that is far away or something that is distant away. So let us look at this part. From the distant convoluted tubule, it leads to the what a duct or a passage we refer to as that is branched down and branched up. The one that branches up is what we refer to as the what renal vein, and blood goes back to the heart through this part. Then the one that branches down is what we refer to as the what the collecting duct. This collecting duct is where all the nephrons empty their contents. Do you understand? So this structure is also a structure of a nephron, one nephron. There's so many other nephrons, millions of nephrons in one kidney. So all of them will empty their what? Their urine or their contents, the urine that's been produced, into the collecting duct. Do you understand? So this collecting duct will now finally pass through the what? Pelvis, and then out of the kidney through the pelvis, and then down to the what? Ureter, and then finally to the what? Bladder, where it is temporarily stored until it is ready to be what? Emptied out of the body. Do you understand? So let us go back to when this blood has been what? Filtered by the what? Bowman's capsule, and forms what we call the filtered fluid forms what we call the what? Glomerulus what? Filtrate. Now this glomerulus filtrate contains what? It is coiled. You notice there's another coiled part around this tube referred to as the interstitial fluid that takes in what? This interstitial fluid can what? Take in some of the content of the Bowman's the tubule, the renal tubule. Can get some content into it through three processes. The first one we call passive transport, the second one active transport, and the third one variability in what? Permeability. That was, it means when the tube has different areas of the tube that is what? Permeable to some substances like maybe water, just like the descending part of the loop of Henle's is permeable to water, meaning that water can leave, and then it is not permeable to ions like sodium chloride and other ions like bicarbonate ions, sodium ions, potassium ions. They cannot leave, they are not permeable, so they cannot leave the what? Tubule to go out, which is what we know as what? Reabsorption. So there's no reabsorption of sodium ions in the what? Descending part of the loop of Henle's. But in the ascending part of the loop of Henle's, there is what? There is reabsorption of what? Sodium. And when sodium leaves the tubule into the interstitial fluid to be reabsorbed back into the body. Do you understand? Why water comes in? Do you understand? So at different segment of this tubule, there is variability in permeability. Do you understand? Being variable, that means they have changes in what they can permit into them, into the tube, and what they cannot permit. Do you understand? Well, now another thing you need to know is that when things are entering into that tubule rather, it is known as what? Secretion. But when things are leaving the tubule to enter into the interstitial fluid, the interstitial capillary, it is known as what? Reabsorption. Because when it enters the interstitial capillary, it is entering there so that it can be absorbed back into the body. A majority of this what? Reabsorption occurs at the what? All areas, both the PCT, the loop of Henle's, the DCT, and the collecting duct. But majority of the what? Reabsorption occurs most at the PCT, the proximal convoluted what? Tubule. Do you understand? So at this proximal convoluted tubule, major things that are being reabsorbed are what? Glucose, like amino acids, some little salt, then things that are being water, then things that that are not reabsorbed, that remain in the what? Tubule are mostly what? Few water content and what? Ions. Remember that the major reason, one of the things, the functions of this PCT and DCT is that they are there to maintain the pH. Do you understand? That is the hydrogen potential, to make sure that the pH there is a bit what? High, so that things can to make sure that the pH there is controlled, not always high, depending. Do you understand? So when this water and glucose, water and glucose are reabsorbed, and amino acid, they leave the tubule into the interstitial fluid to be absorbed by the body. Then getting to the descending part of the loop of Henle's. Do you understand? In that descending part of the loop of Henle's, water leaves also, but salt and ions remain. Then in the ascending part of the loop of Henle's, water is being absorbed and salt leaves and some other ions still remain in the tubule. Now on getting to the DCT, distal convoluted tubule, what happens there is where a hormone secreted in the brain, the part of the brain we call the hypothalamus, secretes a hormone and passes it down to the pituitary. Now in that pituitary, it's being secreted by the pituitary gland to the blood, so that ADH, called meaning antidiuretic hormone, is now used at that point in the kidney and urine formation by the kidney to bring about reabsorption of water. Now, if you hear the word ADH, antidiuretic hormone, from the word diuresis, diuresis means excess, production of fluids, excess urination. And once somebody produces excess water and the person is not drinking enough water, it will lead to dehydration. So the person will be drinking more water and also excreting more water. But because of the hormone ADH secreted in the brain, this hormone comes to reduce the amount of fluid that is being passed out as your urine. So, and it does that at the point you call the collecting dot. It reabsorbs water with the help of this ADH. Do you understand? So this ADH comes into bring about reabsorption, so that the urine formed can be hypertonic, meaning high in concentration, because more water has been reabsorbed. That means more water has left the tube to be reabsorbed into the body, leaving less water and more ions. Do you understand? And also more urea. Now there are some questions that YOU will always ask. Sometimes they will ask questions like, where in the kidney has the highest amount of urea? Urea and uric acid and nitrogenous waste, together with creatinine rather, they are all nitrogenous waste that are gotten from protein meal. So whenever somebody eats protein more, the person has more. So urea, uric acid, and creatinine are gotten from nitrogenous waste, that is waste gotten from diet that contains protein. And because we know that at the end of the digestion of protein, amino acid is the end product, and this amino acid will be divided into two groups: the nitrogenous group and the carboxyl group. So the carboxyl group will be converted into glucose and then stored, of course, as glycogen, while the nitrogenous group will be broken down to produce ammonia. And then this ammonia, because we cannot excrete ammonia because we don't have access to excess water, unlike organisms that reside or habitate in aquatic environments, we need to do to break down this ammonia further, or what we call deamination of protein, to break it further, so that we can now have urea, uric acid, and then creatinine. So at the end of the production of urine, sometimes, just like I said, a major YOU question will be, where is urea highest in the kidney? What part of the kidney has the highest amount of urea? Now the part of the kidney that has the highest amount of urea is the collecting duct.